Hello and welcome to a special GCSE revision video. I've been asked by someone to come up with some questions on circle theorem, so here goes. The longest chord of the circle is called the diameter. The diameter of this circle is 15 centimetres. The second longest chord is 12 centimetres. What is the length of the shortest chord? Okay, good luck with that one. Take your time, pause the video, and when you're ready with the answer, just press play. Okay, so how did you get on? Alright, we're told the longest chord of a circle is called the diameter. The diameter of this circle is 15 centimetres. The second longest chord is 12 centimetres. What is the length of the shortest chord? Okay, we are explicitly told in this question that this 15 centimetre chord is the diameter, and that's important because if two chords subtend a diameter at the circumference, then they must be at right angles. That's one of the circle theorems. That's a property of a circle, that if two chords subtend a diameter at the circumference, then those two chords meet at 90 degrees. So now that we know that this is a right angle triangle, we can go ahead with confidence and use Pythagoras' theorem to get the missing length, which I'm going to call x. So in this case, x squared is equal to 15 squared minus 12 squared. You might even recognise this as a 3, 4, 5 triangle. So this is 4 times 3 and this is 5 times 3. So this is 3 times 3, which is 9. But if you didn't recognise that, that's fine. So x squared is equal to 15 squared is 225 minus 12 squared is 144. So x squared is equal to 81. So x is equal to 9. I know algebraically x could be plus or minus 9, but in geometry there are no negative lengths. So x is equal to 9. Our units are in centimetres, so x will be 9 centimetres. Okay, how did you get on with that question? In this question we're asked, can you find the angle A? Right, take your time, pause the video. When you're ready for the answer, just press play. Okay, so how did you get on with that question? Alright, so we asked, can we find angle A? Okay, well there's two ways we could have gone about this. One way is to consider this chord, which I'm going to put in yellow. So I'm going to take this as the chord. Let's make it thicker so we can see it. So this is the chord we're thinking about. Now, if the angle that this chord makes with the tangent line is 81 degrees, and this angle is in the minor segment, so I'm going to say this is little m for minor segment. So that means that this other side of the chord will be big M for major segment. Now the angle that subtends this chord must be the same. This is called the alternate segment theorem, and this is 81 degrees. And from here we can use the angle sum theorem of a triangle and say that A is equal to 180 degrees minus 81 degrees minus 68 degrees. Alternatively, alternatively, I could have considered this chord here. And then I could have said that this is the minor segment and this is the major segment. In which case the angle that subtends this chord is 68 degrees, and therefore this angle here is 68 degrees. And again, I can say that angles that lie on a straight line must add up to 180 degrees. So again, A is 180 degrees minus 81 degrees minus 68 degrees. So let's just do that. So A is equal to 180 degrees minus 81 degrees. Well, that's going to be 99 degrees, and then minus 68 degrees. Well, if we add 1 to 8, then that makes 9, and if we add 3 to 6, then that makes 9. So I'm saying that's equal to 31 degrees. Okay, how did you get on with that question? Right, good luck with this one. The chord does not go through the centre of the circle, but goes from the point where one tangent line meets the circumference to the point where the other tangent line meets the circumference. If the chord makes an 80-degree angle with one of the tangent lines, what is the angle that the two tangent lines meet? Okay, good luck with that. Take your time, pause the video. When you're ready for the answer, just press play. Okay, so how did you get on with that question? Right, we're told the chord does not go through the centre of the circle, but goes from the point where one tangent line meets the circumference to the point where the other tangent line meets the circumference. If the chord makes an 80-degree angle with one of the tangent lines, what is the angle that the two tangent lines meet? So we're looking for this angle x, and we're told that this angle is 80 degrees. Now, there is a circle theorem that talks about tangent lines touching the circumference and being 90 degrees, and that might cause confusion, but that circle theorem says that a tangent line meets a radius at 90 degrees. It's perfectly okay for a chord to meet a tangent line at something other than 90 degrees. It's only the radius that has to meet the tangent line at 90 degrees. Okay, so that being cleared up, what do we know about tangent lines that meet at a point outside of a circle and both touch the circumference of the circle? Well, we know that this point where they touch the circle to the point where they meet are equal. So we know that this length here is equal to this length here, and therefore this is an isosceles triangle. And we know that the base angles of an isosceles triangle are the same. So therefore this angle here must be 80 degrees. And then we know from the angle sum theorem of a triangle that x is equal to 180 minus 80 minus 80, or 180 minus 160. So x is equal to 20 degrees. Okay, how did you get on with that question? Right, in this question, can you find angles x and y? Okay, take your time, pause the video, and when you're ready for the answer, just press play. Okay then, how did you get on with that question? Right, we're asked, can you find angles x and y? Right, well this is fairly basic, but there's a big trap here. Just be careful not to confuse this. Actually, let's colour that. Please don't ever make the mistake of thinking that this is a cyclic quadrilateral. This is not a cyclic quadrilateral, and the rules about cyclic quadrilaterals do not apply here. The cyclic quadrilateral, it must have all 4 vertices touching the circumference, and in this case this vertex does not touch the circumference. However, this shape is a cyclic quadrilateral. So this is our cyclic quadrilateral. Now we know that opposite angles of a cyclic quadrilateral must sum to 180 degrees. And since this angle is 130 degrees, the angle x must be 50 degrees. So x equals 180 degrees minus 130 degrees, which is equal to 50 degrees. Now, the other shape to look out for, let's colour this in red. Let's make it thick. Is this arrow shape. So we'll look at this red shape. Because if we draw a line from here to here, then we can see that both angles x and y subtend that same red chord. Now y is at the centre, and we know y is at the centre because these two lengths are the radius. So this must be the centre because the radius goes from the centre to the circumference, and the radius goes from the centre to the circumference. So we know that this is the centre. Now, if an angle, or if two angles subtend the same chord, and one of the angles is at the centre and the other angle is anywhere on the circumference, then, or in the same segment, then we can say that the angle at the centre is double the angle at the circumference. So that means that y is equal to 2x. So y is equal to 100 degrees, or 2 times 50 degrees is 100 degrees. Okay, so how did you get on with that question? Alright, last question now. The two radii form an angle y, while the two chords form an angle x. The two tangent lines meet at an angle of 45 degrees. Can you work out the value for angles x and y? Okay, good luck with that one. Take your time, pause the video. When you're ready for the answer, just press play. Okay, so how did you get on with that question? Isn't it a stinker? Alright then, so what can we know? Alright, well let's just look at these two tangent lines here. We know that they're both equal. So if we drop a chord down through here, actually let's use a different colour so that we know what's the actual question and what's our calculations. So I'm dropping a chord down here, joining the two tangent lines at the points where they touch the circumference. And now I can say that this angle here is equal to this angle here because this is an isosceles triangle. And since this is an isosceles triangle, I can find these two angles. So if this is 45 degrees, then these two angles are going to be 180 degrees minus 45 degrees, and the whole lot divided by 2. So that's 180 minus 45 is equal to 135 degrees, and divided by 2, or 2 goes into 12 6 times, leaving a remainder of 1. 2 goes into 15 7 times, leaving a remainder of 1, because 7 times 2 is 14, so that's 67.5 degrees, or 67.5 degrees. So let's pick a slightly bolder colour. I'm going to say this angle here is 67.5 degrees. Now this radius, I know it touches a tangent line, so I know that this is a right angle. I also know that if this is a radius and this is a radius, then this is an isosceles triangle. So I know that this angle here is equal to this angle here, and they are both going to be 90 degrees minus 67.5 degrees, because this is a right angle and this bit here is 67.5 degrees. So I've got 90 degrees minus 67.5 degrees. Well, I'm going to have to add a 0.5 to turn that into 68, so I know my answer is going to have a 0.5. If I add 2 to 8, I'll get 10, so that makes 70, so I need to write down a 2. And then I need another 2 to make 70 into 90, so that's 22.5 degrees. So this little angle here is 22.5 degrees. Which means that this angle here is also 22.5 degrees. Which means y is equal to 180 degrees minus 2 times 22.5 degrees. Well, 2 times 22 is 44, 2 times a half is 1, 44 plus 1 is 45. So that's 180 degrees minus 45 degrees. Well, hang on, we already did that, and we found out that that's 135 degrees. So that's 135 degrees. So y is 135 degrees. Now it might be tempting to say, oh, opposite sides of a cyclic quadrilateral, but we can't because this is not a cyclic quadrilateral because it meets at the centre. However, if we, let's pick a different colour, let's pick yellow, bright yellow, that should stand out. If we draw a cyclic quadrilateral, I can draw it anywhere on the circumference, so long as I'm extending the cyclic quadrilateral into the circumference, then this is now a cyclic quadrilateral if I go over this line here and this line here. So that makes a cyclic quadrilateral. So let's make it thicker so that we can see our cyclic quadrilateral. Now I can take this angle here, and this angle's really easy to find. I can either say it's half of y, so it's half of 135 degrees, so it's 67.5 degrees. Or I could say this angle here is in the minor segment, and this angle here subtends this same chord, which subtends the same arc. So whether it subtends the same arc or subtends the same chord, it makes no difference. So that's going to be the same as this angle here. So this is 67.5 degrees. Now if this angle is 67.5 degrees and this is the opposite angle on a cyclic quadrilateral, then x is just 180 degrees minus 67.5 degrees. So x is equal to 180 degrees minus 67.5 degrees. Right, so I've got to add 0.5 in order to make 68, so I've added 0.5 degrees. I add 2 to turn the 8 into a 10, so I know I've got 2 here, so that makes that 70. So what do I have to add to 70 to make 100? I need to add 30, don't I? And then to make 180 I need to add another 80. 8, 9, 10, 11, so I need to add another 11 to turn that into 180 degrees. So that's 112.5 degrees. So our answers are x equals 112.5 degrees and y is equal to 135 degrees. Okay, I hope you found that practice helpful, hopefully not too infuriating with that last question. If you're taking your GCSEs this year, I'd like to wish you all the best with your revision and all the best with your exams. Don't forget to hit that like and comment and subscribe. Like if you like the video or if you want to see more videos like this. Comment if you've got any suggestions for other videos you'd like to see, and hit that subscribe button if you want to be notified when I upload videos. You'll need to turn notifications on, of course. Alright, I look forward to seeing you in another video.